Welcome back to the channel, everybody. Today we have a 19-inch K7000. This is the, how to identify this is the P447. Right here, P538 is 25-inch, so if you see one, you don't know which one it is. 447 is 19-inch, 538 is 25-inch. The easier way is just to look at the B+ resistor over here. The tiny one here is for 19-inch and the larger one is for 25, so that's an easier way to just quick spot it. And most 25-inch 7000s have the remote harness for the remote adjustment board, but there are some that don't. Like for Ivan Stewart's Off-Road, for example, has a 25-inch K7000 from the factory, but it did not have the remote board because there's no way you can't easily lift the control panel to adjust it, so they just put the pots on the board. So anyway, yeah, the 7000 is one of the easier chassis to work on. So for this video, this is the first in a series of 5 Repair-A-Thon 7000s I'm going to be doing here. This is the one that I cleaned in the previous video to this on the channel. I'll link it down below if you want to learn how to clean these, or at least my method for doing it. But for these, or this one specifically, we're going to go over, I've covered it many times in other 7000 videos, but for this video, we're going to do a dedicated video on what to look at, the important things to check out, how to check those important things, and the normal problem areas you want to focus on when you're trying to revive or repair or just simply go over a 7000 and somewhat make it quote-unquote bulletproof. So yeah, so the first thing I noticed on this one particularly, we'll get to the important stuff later, but let's go over the specifics of this particular chassis. So somebody has previously done a cap kit. They're not Nichicon Nichicon caps. So we'll go ahead and do a new cap kit with the Nichicon ones. Somebody has replaced the shutdown pot with an aftermarket one, and I don't know if it was because they had to adjust it. There shouldn't have been any reason to mess with it unless there was something wrong with the shutdown pot itself or it wasn't adjusted properly. They put the glue on there so you're not able to actually turn it unless you're able to cut it loose, which sometimes you can get lucky with that. So the shutdown pot's been replaced. The R105 thermistor has been yanked out of the solder joint here. This has been yanked right out, so we'll have to reinstall that. And then R89 is super loose in here, so the solder joints aren't even soldered in. They're I don't know if they're thin. We'll take a look at it, but that's all loose. The fuse holder here, I saw the fuse was loose in the holder, and then this is about to bust off, so we're gonna have to replace that. That's no problem. I have plenty of those on hand to replace that, but that's busted. Let's just get rid of that. So we'll change that out. What else? Visually, it's not bad. The neck board is removed because I cleaned all this up. We'll set it aside for now, but visually speaking, it's not too bad now that it's clean. The only things that I noticed visually or physically was the loose R89, the shutdown pot, and the broken fuse holder. So if we look at the back side, yeah, nothing too bad. Just solder joints. If we look here for R89, we can see that it's going to be right here and here. We can see that right there. So there you can see that one's not even soldered in. This one up here, you know what, I bet you I could just take this and pull it out of here. Maybe not. This top one's tough, but anyway, so all right, so the first thing to do here is we're going to go through and just test all the components. So you've got a 7000 that's giving you problems, whether it's not powering up or it's shorting the fuse. Let's go over some of the important things to test and check so you know what to do. Okay, we'll start with the resistors and the power section. So we'll go to ohms here on our meter, and we'll start with R103. R103 comes off the filter cap. So if R103 is open, you'll have either shorting fuses or a dead chassis, depending on what else is wrong in the circuit. So R103 is this guy here. It should be 2.7 ohms, and it'll probably read somewhere around 2.8 in circuit. 2.8, look at that, 7, perfect. So R103 is good. Everything I'm going to show you here is the necessary things to check whenever you have a dead 7000 or a shorting fuse. not short, open fuse. The fuse is opening or blowing because of a short. How about that? Okay, so R103 is good. Then we'll check our rectifier diodes here. The easiest way to check the rectifier diodes is not going to each individual diode. You can go to R104 here. R104 is supposed to be 15 ohms. If you read 15 ohms, your rectifier diodes are generally good. 15.0, perfect. But if you read like 5 ohms or 4 ohms or something like that, then it's likely you've got a shorted rectifier diode. But just for the sake of completeness, we'll go to diode mode on the meter. Negative lead goes on the side with the stripe, and we'll check D19, should be a 0.5 voltage drop. There we go. D20 is the opposite direction. 0.5, D21, 0.5, D22, opposite direction again, 0.5. 23 is this way, 0.5, and 24 is this way, 0.5. So as I stated, all our rectifier diodes are good because we got 15 ohms on R104. All right, so now R101, this guy right here is notorious for having bad lifted and oxidized solder joints, and if R101 is out of spec or open in the circuit, you'll have a 7000 that's dead. So you want to check R101. Now I think it's about 6.5 K ohm is what it's supposed to read, the rating, or 6K, somewhere around there. But in circuit, it might read somewhere between 4.5 and 6. So it's not necessarily important to remove it from the circuit, but if you read between 4.5 and 6K ohm, 4.5K and 6K ohm, it's generally going to be fine. So if we go back to ohms, let me check R101 here. Sometimes the legs can get oxidized, so you want to get a good connection here. If I'm able to. I can't get a good shot here. Let's just go to the back side. So R101 are these two pads right here. R101 goes across these two. So you'll see here that someone has previously installed this little jumper here because the pad can get oxidized, like I say, and burn up. And that seems to be the case here, and the solder joint looks terrible. But if we go to the two pads for R101, we get, there you go. Like I say, between, oh, you can't see it, sorry. Herp-a-derp, sorry. All right, do it again here. Yeah, anywhere between 4.5 and 6, generally 5K, you know, your R101 is good. Like in circuit, it reads a little low because there's other components on the circuit. That's why it's important to read resistors out of circuit. But that's a good reading for R101. Now, R89 should be 3.9K. That's the big ceramic one here that's loose in the chassis. So that should be 3.9K and 3.9. Perfect. If you read out of tolerance on that, it's 3.7. You know, I don't know what the tolerance is, but when you drift down below about 3.8, it's closer to 3.7, or on the opposite end, the same thing. You want to generally replace it. It's a mission critical component for proper B+ operation. So that's good. R88 should be 1.8K. That's this one down here next to R89. It should be 1.8K, and it is. R96 is not installed in this chassis. Some 19-inch 7000s do not have an R96. Some of them do. If you have one, it's supposed to be 1.8K also. It's the same rating as this one when it comes to the resistance. It's a higher wattage, but R96 is supposed to be 1.8K also. So if you have an R96, you need to check it, and it needs to be 1.8K also. But this revision doesn't have R96. If we look at the back, there's no evidence of it ever having been installed. It goes right here. There's no evidence of it ever having been installed before. So there's no R96 on this revision of 7000. Then we have R97, should be 270 ohms. That's this guy right here. And we get 7.9 meg. That's not good. That's why you gotta go from the bottom side here. Come on. 271.0, so perfect. All right. So there's all the components in the power circuit there that you normally want to check as far as the resistors, I should say, all the resistors in the power circuit. Now you want to check the width cap, C38. You want to make sure the C38 width cap right here, this guy, this green guy here, is not shorted. And again, you know, the fuse on this is not shorted or blown. I keep saying that. The fuse is not blown. So it's a good indication if your fuse is not blown, you don't have any shorted components. However, you can have shorted components that don't take out the fuse, but will take out like HOT and things like that. But you want to make sure that your C38 horizontal width cap is not shorted, just to verify. And that's these two leads right here, and we get in the mega ohm. So it is not shorted. So that's good. Next, let's go ahead and just test our HOT, or horizontal output transistor. That's that guy right there. And it looks like somebody has done some type of surgery in replacing it, and they put these little jumpers here to the next pad. They butchered the pads and had to jumper over to it. But we go to diode mode. We should get a 0.46 voltage drop or so to each leg. So diode mode, negative lead on the collector, which is right here, and then to the base and emitter, it should be 0.46 or so voltage drop, or 0.8, 0.47, okay. Other leg, 0.47, so HOT is good. Hypothetically, it's not shorted. Then your critical safety cap. So there is different revisions. Some 7000s have one big cap with 4 legs. Other ones have 2 individual caps with individual legs. So this one is one of the ones with 4 legs. 1 cap, 4 legs. Some have 2 caps separated. Okay, so let's test the C36 now also. It doesn't matter, like I say, this is the 4-pin C36, but it doesn't matter if you have the 2 individual capacitors or if you have a single capacitor for C36. It doesn't matter. The method is the same. So you're going to read diagonally across the pins. There's 4 pins here. There's 1, 2, 3, 4. And you read diagonally from the negative on the bottom 2 pins to the positive on the top 2. And you measure diagonally, you should read the same as the HOT, about 4.7 voltage drop. So if we go bottom left with negative, top right with positive on diode mode, we get 4.7. So now we'll go bottom right and top left, we get 4.7. So our critical safety cap is good. Now I want to take a moment here and talk about how it's important to always check the C36 critical safety cap, because if the HOT reads shorted, you want to remove it from the circuit and verify if it's shorted out of circuit. And even if it is or not, you always must check the C36 also, because if the C36 cap is shorted, it can cause the HOT to read shorted in circuit, and vice versa. So if you have a shorted HOT, you're going to read a short on C36. If you have a shorted C36, you're going to read a short on the HOT. So if you have a short here, you want to remove the HOT from the circuit and then recheck C36. If C36 no longer reads shorted out of circuit, then all you had was a bad HOT. If C36 still reads shorted in the way I just showed with the HOT out, then you also have a shorted C36. But if the HOT reads good out of circuit, then your HOT is not actually shorted, and the reason it's reading shorted in circuit is because of the shorted C36. Does that make sense? So you always want to check that. Okay, so that's good. Now you want to check our, we already checked the width cap, C38, that was fine. Now you want to check your voltage regulator. So I'll show you the more roundabout method here. So we'll go to diode mode in diode mode, and wait, we'll go to diode mode in diode mode. We'll go to diode mode. The meter is already in diode mode. There we go. So there's 2 different versions of the voltage regulator. Let me see if I can find here. Okay. I have another 19-inch chassis here, 7000. We'll show you how to read that other version here. But this is the version with the fat one, the STR3123. STR3123 is for a 19-inch only. The STR3130, I believe, is for the 25-inch. So you can't intermix them. This runs at, I think, 124 volts. And the 7000 for the 25-inch runs at 130 volts. So there's a specific specific regulator you need for 19 versus 25, but we'll get to that later in a different video. But the STR3123 is the correct one that's installed, so that's good. But this is the wide fat one. There is another version that uses the tall skinny one, like this. They're both an STR3123, but this is the tall skinny one. And this is the fat one. So on the fat one, the way you check this is in diode mode. You put your negative lead on pin 1, your positive lead on pin 4. You should get a 0.150 This is 19. 0.150 voltage drop? 0.16. Okay, so on the 25 inch it's 0.150 because the B plus resistor is larger. But you should not get a short here, and we don't. We have 0.165 because we're reading through the B plus resistor. So this is a good reading for this voltage regulator. It's important you just make sure you don't have a short. So that's the roundabout method. You can also just simply go right to the B plus resistor. This resistor is supposed to be 220 ohms. The 25 inch is 180 ohms. On the 19 inch is 220. So if we go to ohms, if you suspect your voltage regulator is shorted, the easiest thing to do is just go to your B plus resistor and make sure it reads 220. Oh, well, interesting. That is low. Well, the regulator is not shorted. If you had 0.0 ohms across here, your regulator is shorted. So the easiest way to test your voltage regulator is just go to the B plus resistor, and you should not have 0.0. But am I wrong here? Let's grab this other one here. Oh, wait a minute. I am wrong because there's an extra resistor here. So that guy right there is making it read. Okay, so normally if this wasn't installed, some of them have them, some don't, but that's why it's reading what we... Okay, so without this there, it'd be 220. Okay, well, so I bet you... See how this one doesn't have that extra resistor? Like I say, some have it, some don't. I'll bet you we read 220 on this one. Come on. Huh. Well, obviously we're reading through something else in the circuit. I'm not really going to be too concerned about it. Tighten that boy up. There we go. Well, yeah, I mean, 220, you need to test resistors out of circuit. You can't normally you need to test resistors out of circuit because if they're in circuit, they can be influenced by other things on the circuit. So I'm not going to complain too much about that, but okay. That other one read that way because of that extra resistor. Okay, so now, oh man, I'm getting flustered here. So on the regulator, that's the tall, skinny one, it's pins 3 and 4. So on this one, it was pin 1 and 4. On this one, it's pin 3 and 4. So if we go to pin 3, 1, 2, 3, 4, 5, pin 5 is not used. On any 7000 you have, pin 5 on the regulator is no connection. It's NC. It does not go anywhere. There's no connection. It's only pins 1 through 4. Pin 5 doesn't do anything. So on the tall skinny one, negative lead on 1, 2, pin 3, and then pin 4 you should have that same 0.16 voltage drop in diode mode. There you go. So that's how you test the tall skinny one versus the fat wide one. Now we can put this one away. And we'll get back to this. Okay. So, yeah, sorry about the confusion there. I expected this to be 220, but with this extra added resistor here, it's about 200. So that's normal. Like I say, you're just checking to make sure that it's not reading 0.0. So, is that everything? I think that might be everything that we need to test. Obviously, make sure your fuse is good. You know, it's not visually destroyed, but yeah, it's fine. All right, those are the mission critical components to test in the power circuit on the K7000. So let's say that you've got a dead 7000 and everything that we just checked checks fine. Nothing is out of spec, nothing is missing, nothing is broken, nothing is burned, nothing is shorted. Everything that we just checked seems fine. So you want to do a light bulb test. Well, how do you do a light bulb test on a K7000? Well, let me show you. First thing we have to do though is we're going to have to fix this R105 thermistor. You can't see what I'm doing here, so we're going to have to get this guy back in circuit here. Oh, I didn't have my iron on because I didn't expect to do this. I'm going to cut away, come back, the iron will be ready. The iron will be ready, easy for me to say, and we'll continue on here. In the meantime, I'm going to try and find another fuse holder here because I have to change that out. I need the fuse installed to do the light bulb test. So while the iron's heating up, I'm going to find a new fuse holder and then I'll come right back. All right, so new fuse holder required. So let's get this broken one out of here. Okay, that's out. Let's get this one in. Make sure you put it in correctly. So there's a little tab here for the fuse to rest against. So you don't want to put it in, you know, backwards. You want to make sure it's in there the right way. So it needs to go in like so. Okay. All right, that's good. And that's good. All right. Now we need to get our 105 thermistor back in here. And these solder joints are so dry and brittle that I'm not surprised that this happened. All right, now we got to get R89 in here. So part of this video, I'm gonna show you how to clean up solder joints and solder pads and stuff too, but just for the sake of doing our light bulb test, I'm just gonna solder this back in because I want to clean up these R89 pads, but I'll show you how to do that. So, okay, that should, the leg of R89, both of the legs are oxidized. That's why the solder joints aren't sticking, but quick, you can rub the component leg with your iron and clean off some of the oxidation, and then it'll stick pretty good. So, all right, let's give this a look over. I want to hit up, well, I want to show you, look at these solder joints for the regulator. This is pretty thin. Look how thin that is. Not shiny, dull, thin. It should not look like that. These are the reflow I just did on R89, if I could find it. Yeah, see, that's what you want those to look like. So, yeah, I'm not going to reflow it just yet. I'm sure it's probably going to work just for the light bulb test, but let's take a look and make sure there's nothing else that is broken or needs to be. I kind of already did that, but let's look again. Oh, look at D18. I didn't mention D18 because it's not mission critical for power, but D18 is this little diode in there, right there. If we look at the solder joints on D18, yeah, it's seen some heat. It's partially even cracked there, right there. Look at that. That's no good, and that's oxidized and no good either. It's cracked as well. So D18, pff, that's bad. One thing that I always do when I reflow these chassis is I will simply, I really don't want to do it now. I'd like to clean up that pad, but I will just create a giant solder bridge from this joint, from this thing to this thing to this thing, just one big giant solder bridge, because this is the horizontal yoke connection and it gets very hot. So I create extra surface area with solder to help dissipate some of the heat. So I think just for now I'm just going to go ahead and just do this. Now that pad's gone. The pad's not gone, but I tried to reflow it and it just completely, it's the whole, oh, gosh darn it. I want to use that as an example of fixing this. So I think what I'm going to do is I'm just going to bend this over to there. I just bent, you didn't see it, but I bent the leg over to that joint, and I'm going to just do this because I want to use, I want to use this as an example of how to fix pads like that. The pad's still there, but it's so oxidized that the solder can't stick to it. So I want to show an example of how to fix that in this video. So we'll use that. All right, so was that it? Is that, yeah, it's very important also when you do reflow is you want to reflow everything on the horizontal width coil, because if this width coil comes out of circuit, it will burn this whole thing. This whole thing will become a giant fire, and all of this will just burn in glorious fashion. So you want to absolutely verify that you've got good solder joints on your horizontal width coil. Those are all extremely dull and thin and oxidized. So I guess we can go ahead and reflow it now. I'm just trying to take care of some things that we need to do eventually. but somewhat prematurely as well. This is all one big joint, or not joint, one big trace. So I mean, if you wanted to, I mean, you could even just solder bridge all this stuff together if you wanted to. I mean, it doesn't look professional and it's not necessary, but I mean, if you wanted to, you could do that. There, see, there's one. I don't know if I'll be able to do that. I gotta let one dry first. You can't see what I'm doing, sorry. I gotta let one dry first, so then we'll hit this one and that one. It's all just flow into the next one. Might have to forget it. Hey, there we go. And you can't see it. Sorry about that. There we go. Okay. So I think that's okay. This is turning into kind of a clown show here, but we'll call that fine. Okay. Now, I think that's fine for now. So let's go ahead and, well, I think actually R101, let's make sure it's got continuity here. And yeah, not good, but it's there. All right, well, okay, let's get back on track here. So all that stuff is taken care of. Let's talk about how to do light bulb test. All right. So I probably should make a dedicated video, but we'll include it in this one also. So how do you prevent the chassis from powering up on the bench without a CRT needed? Okay. Well, you want it to power up it. So you don't want to just, if I just plug this in the wall and turn it on, not the wall, I'm sorry, not the wall. If I just plug this into the test bench here with the isolation transformer, that's very important. If I just plug this into the test bench here with the transformer and turn it on, you're gonna have all kinds of, you're gonna not be enjoying life very much. So how do we prevent the flyback from turning on? How do we prevent the output to the chassis, to the tube from happening? You can remove the HOT from the circuit. If you remove the HOT from the circuit, that will prevent the horizontal output from powering up. So the flyback won't turn on, you won't have any output to the yoke, nothing is gonna power up except just the power supply. So you can test the power supply. If you go to backtrack a bit, if you have a 7000 and you have checked everything imaginable in the power circuit like we've just done, and it's still dead or not working, to help aid in troubleshooting to find out if you have an open trace or another open component or a bad solder joint or something like that, you can perform the light bulb test. If your light bulb test works, you know your power supply is good and it's something else, likely IC2. If IC2 is bad, it'll keep it from powering up, or your shutdown pot's not adjusted properly or something like that. But if that light bulb lights up, you know your power circuit is good, you can move on to other things. If it doesn't light up, you know your power circuit's the problem. It'll help you isolate power supply versus horizontal output side. So the easiest thing to do is to remove the HOT from the circuit, and that'll prevent the output from powering up. So there's two ways to do this. Just remove the HOT completely, or the method that I like to do is to save you some time, just remove the collector from the circuit. So if we go down here to the HOT pads and we simply just remove the collector from the circuit, that's all we have to do. And let's remove that. I'm not sure why they put that jumper in. It looks like the pad's in just fine, or the pad's in good shape. Okay, so that is desoldered. Now we just need to make sure we don't have continuity on the pad. So if we go from here to here, that's fine. I meant the pin, continuity on the pin. So from here to here, all right, so that's fine. Now if the pin is nothing. Okay, so if I move the pin around, continuity, no continuity, continuity, no continuity. So the pin is removed from the trace. So now that's the same essentially as removing the HOT completely. So now all we have to do is grab a light bulb. Let's do it this way. All right, let's grab a light bulb. And I've got this set up here that a viewer sent in. Thank you very much for that. We clip on the frame with one lead. Other lead goes to the blue wire. Wait a minute, no, let's see, I have that. I think it's the red wire. I'm trying to remember. No, it's the blue wire. Okay, the blue wire is the regulated side. Okay, so there's a blue wire and a red wire. The blue wire is the regulated side, so we should have 125-ish volts, 123-ish volts when we plug this in. So, the power connector is actually missing. Somebody depenned it, but that's fine. We can just do this. That'll be fine. Okay, so now we get the meter here. Go to volts DC. I need some leads. So this, like I say, this will prevent the HOT from allowing the horizontal circuit to power up. And knucklehead, wrong one. And we can test our power supply without having to have a picture tube. Okay, now there we go. That's the setup, and we should be good. So I'm going to turn on power, and we should have a light bulb. We should have 123 volts if our power supply section is good, which all of our testing indicates. So here we go. 1, 2, 3. Oh, I am dumb. I forgot to put the fuse back in. I got the holder and everything and forgot to put the fuse back in. Okay, take 2. Here we go. 1, 2, 3. There you go. We're a little low. It's 121. Should be 123 if memory serves. However, it may not be actually 123 because we don't have... This is determined upon the wattage of your light bulb. So this is a 60 watt incandescent bulb. If I had like a 75 watt, it may be 130 volts. It may be 119. The number you get is dependent upon the wattage of the light bulb that you're using. So I believe it should be 123 volts. We're at 121. What was 121.8? So we're only 1.2 voltage lower than what it should be under normal circumstances. So I'm going to call that okay. But that's how you do a light bulb test on a K7000. So now we can solder that HOT back in circuit. And, I mean, for all intents and purposes, we could reattach the neck board and power this up and see if it works. I am not interested in that, though. What I am interested in is getting this all reflowed and all that jazz, and then show you how to fix these oxidized pads, things like that. Okay, so we're done with the meter. I'm going to put this away. So we have verified that our power supply section is now good after reinstalling R105 and the R89. So all of our tests indicated that that should be the case. So now if we go through all this and it doesn't power up and doesn't work, then we know it's not our power supply. It could be IC2 or an open cracked joint or something. But we're not going to worry about that. Let's go ahead and do this repair on D18. So, and again, you know, you don't have to put big solder blobs on the horizontal width coil, but that helps dissipate some of the heat by having all this extra solder. It doesn't allow the pads to burn up as much and oxidize as much. So it acts kind of like a heat sink to have all this extra solder there. It doesn't look good, but it'll help with longevity. So D18, let's fix this pad, and I'll use this as an example. I'll probably use R101 as an example as well. So let's go ahead and, so as soon as I tried to reflow that, the moment I tried to reflow that pad there, all the solder just lifted right off and it's oxidized and it's no good. So let's see if we can fix this. All right. first thing, let's lift this back off of here. And let's just push it down through the hole. Down through the hole. Really? Come on. Why won't you? Do I need to? I'll probably have to do both pads. Let's just remove D18 completely and just fix both pads, because it's likely that's what's going to have to happen here. Man, it does not want to come out of there. There we go. That was stubborn. Stubborn, eh? So now, let's fix this pad here. So, this one here has nothing left for the solder to stick to. The pad is still there. The pad's there. It looks like it's gone, but it's not. It's just so oxidized from heat that solder won't stick to it. So let's revive it. What you want to do is get yourself a fiberglass pen. I prefer an actual fiberglass pen. The ones you find on Amazon, like with the red and the yellow handle, those aren't actual fiberglass. This is actual fiberglass. This is used for sanding body parts, body panels on cars. This is actual fiberglass. Those other ones are more like a polisher and not a actual fiberglass pen. So I prefer these. I'll link this down below. And then what we do is we just gently sand this. And you can already see that it's being brought back to life. Look at that. Shiny and new. And then we'll do the same for the other one here. There you go. Look at that. Amazing. So, and you see it doesn't take much. So I prefer that pen over the crappy ones you get on Amazon. And then it's just going to come down to putting D18 back in. And I don't think we ever actually tested D18. I reflowed it and soldered it back in, but we never actually tested it. So if we test it here, we're done with the meter. Yeah, okay. We go to the side with the stripe, which is this side over here on the right. So we'll flip our leads around and we get 0.5. So D18 is good. It does look a little haggard, but I'm sure it ran a lot hotter than it should have because of the bad solder joints. So we can reinstall this now. And you can use the bottom side of the chassis as a template for the legs. Like if you need to bend them over and things like that. Okay, so that's good. That's good. That's so good. But it's also important to clean up the oxidized legs on these components as well, because you want the solder to stick to the leg also, not just the pad. So we'll do a little fiberglass penning on the legs of this thing, and that should be good. And we'll grab our brush here and brush these remnants of fiberglass bristles into the trash so they don't end up in my forearm. Okay, now we'll get D18 back in, and it goes in like this. Well, I guess that's as good as any way to hold it in there. All right, that's back in. And let's see if the solder sticks to it this time. Beautiful. Look at that. Fantastic. Outstanding. And let's trim this off because it wasn't sitting flat before. There we go. Awesome. Okay. Now, like I said before, these pads can oxidize also, so to prevent that from happening, I just bridge all this stuff together just like that. Oh, don't flow that way. Come on. Come on down to me here. This. What in the world is your problem here? Man, I'm having a tough time with examples here today. Ugh. Trying to get all this together here. There we go. Man. So I know it looks ugly, but that will not only help with the oxidizing of the pads, it'll help prevent cracking of the joint from plugging the yoke connector in. I can't tell you how many times I've seen these with cracked joints around the yoke connections because people slam the connector down there and just crack the joint because there's nothing holding the joint together except one little piece of solder. And it just doesn't work out so well. So there we go, there's that one. And then we'll do these together here. And we'll do these together here. All right, so that is what I do for the yoke connector. There you go. Now we'll have to hit up C38 here as well. If your C38 is not in circuit, that'll be a bad day. All right, those look okay. All right. And the horizontal position jumpers look fine. We'll have to hit this one though, and that. So this is, I believe, one of the resistors for the width coil. This is the other one. That's fine. Now let's do our voltage regulator. So people throw the word reflow around, including myself. When you're simply adding new solder to an existing joint, that's not really what a reflow is. Reflow, technically by letter of the law, is remove the existing solder, clean up the pad, and flow new solder. Well, that's a lot of effort, so it's easier to just say reflow when you really mean add new solder, not remove existing and replace, but that's all right. So let's do our C36 here. All of our flyback pins look pretty good. Let's hit up R92 and R91. And anything else here? Flyback doesn't look too bad, but I think someone's already reflowed it. All right, we need to hit these two. Basically what you're doing is you're going over and looking at anything and everything that is oxidized or looks like it needs reflowed. That's basically what the purpose and journey of all this is. One thing to make a special note of are these interconnect pads for the ribbon cables for your neck connection. These like to get oxidized and not have a good connection, so we got those. And of course, make sure you don't create any bridges when you're doing this. that would be a bad day also. So yeah, it's one of the important things to get are these interconnectors for your neck board. So we got those. Next step is there is a ribbon cable here. The 3 joints here and there like to get cracked all the time as well. So those are right here. And right here. Case in point. This one here is, see, look at this one compared to that one. Super thin, that's a nice one. This is super thin and almost nothing. So we're gonna have to hit, I'm gonna hit all 3 of them, but that one there is almost nothing. Yeah, I just barely touched it with the iron and it moved right over, so. All right. Zoom back out here. All right, we need to hit the degauss coil because that's thin. We'll hit up that one, other side of our fuse holder. Q10, I believe this is. Q10 can get pretty thin. That's good. So Q10 is these right here. Right there's Q10, and that's this guy right there. That's part of our power circuit also. This little transistor right there. But it's almost never bad. I think I've probably replaced it once in, how long have I been doing this? Since 2005, so 18 years. I think I've only ever changed it once or twice. R103 is fine. Let's hit our video input header pins. That's a must on all these. Yeah, those look okay, but I'll hit them anyway, that one, so. Okay. Let's take a look. Anything else that needs it? We'll have to look at this one here. And that. And this. Okay. I could probably go and do this off the camera so you don't have to sit here and wait for me to get all this done, but yeah, I think for now that's fine. Okay, I think for now that's fine. Let's reflow in HOT and we'll fix R101, and then I think that's going to be about it. I'm not going to do the recap on camera because it's already been recapped. B, there's a million videos out there of recapping a chassis. Maybe I'll do a recap on the next one and show that, but for this one it's already long enough, so it's already been recapped. I'm going to put new Nichicon caps in here because that's not what's in here. So I'll do that off camera, and then what we'll do here is we will just finish this up and then test it, get it working, and make some adjustments and call it done. I'll show you how to set the shutdown pot, make sure everything's honky-dory and operational, and then I'll do the cap kit and finish up some of the more strategic reflow later off camera and call this one done. But for now, let's go ahead and get the neck board reinstalled, and then, well, not in that order. We'll get the neck board reinstalled, we'll fix up our 101 solder joints, reflow in the HOT, and then that'll be about it. And then we'll see if it works. I'm assuming that it will. I don't know. I bought 5. This is the first in a series of 5, like I say, we're going to be doing, and I don't know. It was unknown condition. All of them were unknown conditions. So, yeah, let's get this HOT back in. I'm unsure as to the reason of this jumper. I'm actually going to take this jumper off of here. It doesn't need to be there. The pad is in perfect shape, so we'll just do that. All right. And this one, that one is definitely lifted, so we'll have to keep the jumper on that one. Okay, that's fine. Looks like crap, but that's fine. Okay, now R101. I forgot to mention that some of the stuff I like to do also is that R89, both of these pads like to oxidize very badly, both of them. So what I do is I like to prevent that from happening in the future, I like to just, again, put a big bridge across here, like so. Which you couldn't even see, sorry about that, right there. I'm so bad at that, sorry. Right there, I put a bridge across there for R89, and this one up here, we can just do this. There you go. That's not bad there. Okay, so now that will prevent R89 from really ever coming out of the circuit again like it was before. So now we need to fix this side over here with R89. I'm sorry, no, R101. Let's get this fixed up here, and that'll be the last step. Then we'll get this tested and back in operational status. Don't need that anymore. All right, so again, it's the same method here. We will lift this leg out of the circuit if it will let us. It won't let us. Go through there, you. Man, that is stubborn. I can't scrape this if you're in the way, you stupid thing. Let's see if we can do it this way. Jeez, man. So there, and that's out now. All right. Now let's fix this pad here. Same method. Fiberglass pen. Go in a circle. And voila. Get rid of this in the trash can. And there you have it. So now we want to clean. See, look at the leg here of the actual resistor. It's oxidized as well, so we want to clean this off. See it now? And we'll get this back through here and do the other side. I don't know why this is giving me such a fit here. There we go. Get that back through there. Okay. Now I want to clean up the other side of that. Okay. Now that should solder up quite nicely. Couldn't ask for a better result. That is beautiful. Okay. Now to prevent this issue in the future, we're going to put a big bridge across here. Going to try. Now, in a perfect world, you'd sand off the trace and make it easier on yourself, but that's why this is the amateur channel. But that's what this is what I do on every 7000. I bridge that. I bridge that for R89 for reliability for R89, easy for me to say. And then I bridge these two joints for reliability on R101. And you'll never have to worry about those getting lifted or broken or going bad in circuit ever again unless something else catastrophic happens. So, all right, I think that'll suffice for, oh, nope. Dun, dun, dun. Look at R104 here. Look at this. It's still in circuit. It's not loose, but look at this joint compared to that one. I missed that one. It's still connected and touching, but only just barely. So there we go. Beautiful. All right, let's get this neck board reconnected and fire this puppy up and see if it works. So we simply just reattach. There's two connections, and you can't mess them up because one of them, it has an actual connector like this on that goes to here. The other one has a connector like this that goes to there. So you can't get them backwards. So if we plug this one in here, like so, the other one into here, like so. All right, now we need to connect our G2 wire and resolder in our focus pin wire. Someone's already done a number on destroying this thing. Man, that's terrible. I need to get some of that out of there, but I don't have 3 hands. I'll fix it later. For now, let's just get it soldered in. Okay, that's good. That is not going anywhere. Okay, is that it? Let's clean up a bit. All right, I think that is it. Need to reattach this, not crucial, but we'll reattach it. And we did our light bulb test, and that shows that at least our power supply section is good. So assuming we don't have any other problem, this should fire up. We didn't do a complete total inspection, but that's the breaks you get when you're trying to do this and not have a 3-hour long video. Okay. All right, so I guess we'll grab a tube and get this plugged in and see what we get. Let's set all these to, I'm gonna wipe these all back and forth and set them to nominal for a baseline of what we get here. Wiping these back and forth will kind of knock off some of the oxidation and, I don't know, rebreathe some life back into these pots if they've been sitting in one position for years and years and years. So, okay. All right. I'm assuming the shutdown pot's going to be somewhat close, but let's get this on a tube and fire it up. If it operates and runs and works, we'll get the meter set up and read the shutdown pot and see how it works. It's probably going to be easy to explain this before we do this. You know what, let's just see if it works first, and then we'll worry about explaining the shutdown pot later. Let's just see if it works and go from there. Actually, I went to get my tube for the 7-pin small neck, and I realized it's in the frame that's really encased, and you really can't see anything or do anything or take any measurements or adjust anything. So I'm going to show you how to do this adjustment here on the shutdown pot off of the frame, because we won't be able to do it or show you. I can adjust it, but I'm not going to be able to show you what I'm doing while it's on the tube. So what you do is you go to the cathode of D12. So D12 is this guy right here, D12, and you go to the cathode, which is the side with the stripe. So you'll take a alligator clip and you'll clip on to the cathode of D12. You'll clip on the cathode of D12 like so. So now we're clipped onto the cathode of D12, the side with the stripe facing R104, and then you put your positive lead on that connection. and the negative lead just goes to the frame. So you'd take your meter, put it in volts DC, positive lead on the cathode of D12, negative lead to the frame, and that's where you'd measure your shutdown. Then you would adjust the pot as necessary. Now if we were to go to ohms, I think we're actually on 4.2. If we adjust the pot, you can see the reading changing. So let's see if we can grab this other one here. And you can see why somebody replaced that pot to adjust it, because this one is covered in glue, and that glue is hygroscopic, so it can actually cause corrosion and problems down the line. So let's measure what this one reads and set this one here preemptively to whatever this one reads, and just make sure it's within the ballpark. So this one actually reads 640 ohms, 1.2K. Well, I may be reading through something else here. Let's read what this shows here. 1K. This one is, that may be the totally wrong shutdown pot. 640. All right, well now you know how to read it. Let's turn this over and see what's going on here, because we've got two conflicting readings here. If we go from here to here, we get 640 on this one here that I know is fine. If we do the same on this one, we get 1K. But it's 1.8 to both. 1.08, I'm sorry, 1.08, and the other leg is 1.09. Is that just simply because we're set to the middle? It does appear to be that way. So let's grab the driver of screws and set this to where it reads 640 like the other one in the same way. 1.3, that is the wrong direction. Let's go right there. 800. Trying to do this little preemptive stuff because I can't do any of this while it's actually in the frame of the chassis, of the tube. 593, so that's close. So let's just tweak this a little bit more counterclockwise. We'll go right there. And now we get 680, close enough. Okay. All right, so a little preemptive work here. You'll see what I mean here in a moment. Okay, let me get on a tube and we'll see. Okay, so this is the frame I was talking about, where it's very hard to really get in and do anything with. So it's not wide open like most of the other frames. This is the small neck, 7-pin skinny neck, if you will, frame. So it's hard to really get in here and do anything. You can see that the B+ pot, the shutdown pot, is in there, and it's right below under the tube and under the yoke, and it's hard to even get to. So hopefully we don't got to adjust it, and it's somewhat close to 9.8 volts. So we're all set up and ready to go. We have our anode, neck, yoke, ground, remote, power, video, all critical 7 hooked up prior to power energization. I realize there's no remote board, but I just refer to the pots as the remote, so I always count to 7. So all critical 7 is hooked up. Always make sure you count to 7, anode, neck, yoke, ground, power, video, remote, before you power up a chassis, and you'll never make a mistake with leaving something unhooked. So we're all hooked up there. TPG is hooked up and turned on. We are on the cathode of D12 with our alligator clip, power right there, and then the ground goes to the frame, which I have over here. And it should be 9.8 volts. So assuming this powers up and works, I didn't mention the flyback. The flyback is a white knob flyback, which have a bad rap for being cracking and failing, I should say, or not being reliable. But this has been on here for almost 40 years. So I'm going to continue to use it. If it does work and operate, I don't like to replace parts just for the sake of replacing them. If this operates and works, I'm leaving it in there. I'm not replacing it because there's no actual guarantee the replacement will be any more reliable or better than the original one. So we're going to leave that one in there if it works. So assuming this powers up and operates, we will check our shutdown pot, set it to 9.8 where it needs to be, 9.8 volts DC, and we've explained how to test that and do that. And then we'll check our B+, make sure it's 123-ish volts. We know that should be okay. All right, so let's turn it on and see if it has life and what kind of condition and what we're dealing with this. So here we go, 1, 2, 3. It does turn on. And look at that, 9.9. I might not even mess with it. Do we get a picture? Yes, we do. This is a working and operational K7000. Look at that. Fantastic. And we know it wouldn't have worked before because R89 was completely out of circuit. And R101 was burned up. It had bad circuit pads as well, or bad trace pads. So, yeah, I may not even mess with that. He says as he attempts to mess with it. So the pot is right there, and I'm not even sure. See, I can't really even see it when it's in here. I'm not going to mess with it. It's supposed to be 9.8. We're at 9.92. That's perfectly fine, close enough. So, and yeah, RGB. Yep, fantastic. It's a bit out of focus. Let's go to conversions here. And let's adjust our focus a bit here, a wee bit. Oh nope, that flyback's a goner, because that's all the way counterclockwise, and we don't really get good focus until. Nope, I mean that's 100% clockwise. That is that screen focus pot is maxed out completely all the way to the right, completely, and. It should not be that way. It should be about 2/3 clockwise, and we're 100% clockwise, and it's still not quite focused. If I move it ever so slightly from 100% clockwise to counterclockwise, it just gets more out of focus. So that flyback is going to have to be replaced because the focus resistor internal is out of spec, and we have to have the focus maxed out to get somewhat decent focus, and even then, it's not perfect. So, okay, but regardless, we have a functional, operational K7000. So I will recap this with the Nichicon caps, change that flyback out, do a little bit more touch up on some reflow, and I will clean up the chassis with some alcohol, get rid of all the flux. That'll be about it. So I think everything I wanted to cover in this video is now done. We have shown what to check, how to check it, all the common plagued failure points, how to adjust the shutdown pot, easy for me to say, and how to do a light bulb test, what the B+ should be, differences in the voltage regulator, all that stuff. So yeah, if you have a 7000 that's shorting the fuse, or the fuse is, let's see, it's shorting the fuse, or the fuse is good but it's dead. If you have a dead 7000 with no fuse shorted, a dead 7000 with the fuse not shorted, I keep saying that, blown, a dead 7000 with the fuse good, a dead 7000 with the fuse blown, or a dead 7000 completely, we have gone over all of the normal components you need to check in the power circuit and all the normal common plagued failure points and things, how to fix that stuff, how to check it, how to look at it, how to do shutdown pot. B+, we can go ahead and just disconnect this from the jumper. And see, I can't even read this darn B+. Let me turn this off and disconnect this from the D12 here. And we're going to have to slide this out and hook up this to the blue wire here. Come on, you rascal. There we go. Now we'll have to put this back in the frame. Okay. Back in the frame, let's connect our meter to here. And let's read our B+. Here we go, 1, 2, 3. There you go, 122.9. I flashed to 120 there for a minute, but it should be 123 volts on the 19-inch. We have 122.9. Good. And we're still working. So that about covers everything that I wanted to cover. Sorry, I'm very scatterbrained. That's why it's the amateur channel, but hopefully you learned what to do. If you have a 7000 that's giving you fits, this is the basics of what to test and how to test it and what to do and everything. So I appreciate it. Like, share, and subscribe. Stay tuned for more. Got 4 more 7000s right here in a giant box. So we'll get to those later. Next in succession, 2, 3, 4, 5. So stay tuned for those. Appreciate it. Like, share, and subscribe, and we will see you next time.